So let's take a look at correlation coefficient, review it a bit. Correlation coefficient would measure the strength and the direction. It will tell you the strength and the direction of relationship, right? That if one varies with another, it will have a high strength. If not, then it will have the low strength in terms of correlation. The symbols is R and rho for the sample correlation and the population level correlation. You use rho to explain that. By now, I suppose that you can now distinguish the difference between population parameters, which can never be calculated. It's like the notation that you have, like mu, rho, and the samples parameters like sample correlation or R here, that we can calculate the values based on samples. Okay, there are actually a lot of methods that can be used to a number of methods that can be used to calculate correlation. One of which is the Pearson correlation, which we'll use here. Right. So the basic idea of Pearson's correlations. This is the review of the one that you have already learned that before the midterm, right? If you have a number of observations like this one, x1, y1, x2, y2 to xn, yn, we can assess the relationship by looking at the variation if they vary together or on the positive side or on the negative side. So if x and y, so I'll just draw the same graph there. If x and y have positive relationship, right, large x should pair with this is x, this is y. The large x should pair with the large y, right? Here, large x should pair with the large y, and small x should pair with small y. So if you have the data that tend to behave like this, that means the data have positive relationship. On the other hand, if large x instead pair with small y and small x pair with large y, this indicates the negative relationships. So by looking at the variations, we can determine the either the relationships are positive or negative, and that can be measured using covariance. For the covariance, I would like to note here that you can see that the covariance compare the value x with the mean of x and value y with the mean of y. That means that correlation is affected by outliers, right? Oh, your midterm score, right? Almost done. Well, finished in terms of the multiple choice, but not finished yet in terms of grading of the explanatory part. I will do that quicker. Right? I will try to finish before the due anyway. Try to finish in the weeks or two. So here we have covariance. It will tell you whether x is more than mean and y is more than mean together, or if it's less than mean together, and that will indicate that you have positive relationship. On the other hand, if x is more than mean, it has a plus value, positive value, and y is less than mean, has negative value. Multiplication between the two will give you negative value, thus indicating negative relationships, right? So by here we have the direction of the relationship combining together with the variation within x and variation within y. You have correlations, right? We have take a look at this already, so I will just move on. Correlations have value ranges from -1 to 1. The strength of the value depends on the certainty that there is like relationship between the two variables. Uncertainty will occur if the data contains variations, as you can see here, that R is 1 if the data contains no variations at all, that you can determine exactly that one change and another will change. This often occurs if you have the derived variable, that those variables are derived from another one. But these two, you can see that they are lower than this case and have higher spread, higher variations. So in terms of the strength itself of correlation, the strength indicate the variations, right? Whether or I would say the certainty it indicate the certainty of the correlation. Okay, strong relationship have value close to 1, strong negative close to -1, weak relationship have value close to 0. Okay, so you may use this rule of thumb that you can define the strong by having strong relationship, have correlation more than maybe 0.8. Weak, well, depends, you can have less than 0.3, less than 0.4, and 0.5, those are fine. And the others will be like moderate level. Now these are the graph, the scatter plot actually of the data, two variables. If you plot and the corresponding correlations, estimate correlation. So you can see that the positive slope give you positive value equal 1 if there are no variations. The value will decrease, right? The value of correlation will decrease as the variations increase. And on the other hand, if the slope is negative, then you have like higher. No, if slope is negative, you have negative direction, but the strength will increase if you have less variations. Or in other words, that the change is certain. If you have different slope, it will not change the value of correlation at all, except if you have zero slope, and that would generate a case that you have zero correlations. All right, correlations in other cases that are not linear would be low, approximately. All right, so these are relationship between correlation and shapes. Let's jump to R and assess correlation, and then we finish the first part to see the correlations and move on to the linear regression itself. Okay, I'll switch the screen here. Right. So let's first I'll use the empty car data. So what I will do is to load the empty cars, and you see here there's the empty cars, creating empty cars here. To remind you again, these are the measurements. In rows, each row contains a unit of analysis of each car, and columns indicate the measurements or the spec of the car. So we can use the correlation call to find the correlation between variables, and you can see that comparing to its own, obviously the correlation will be 1. But if you look at this, like MPG is the mileage per gallon, how much fuel consumed by this specific type. Comparing to other variables like the number of cylinder, displacement, you can see some types of negative relationship with high value. So these indicate high correlation between them. Okay. Now we can plot the correlation and take a look from let's look at weight and MPG, and right, you can do empty cars plus geom histogram, oh no, sorry, geom point, I suppose, plus geom point, and aesthetic mapping of x equal WT and y equal MPG. Just that. Oh, haven't loaded yet. Rivalry ggplot2 or tidyverse will do. Here you can see the negative relationship, that it looks like a negative slope here, down here. And when we look at the value of correlation between MPG and WT, that equal minus 0.8 0.867, right? Very high negative correlation, and you can see that the decrease in slope here. Oh no, the negative slope here. Next is for HP and displacement. HP and displacement. Change this to HP. DISP. And here looks positive, right? Let's take a look at the value correlation of the MT cars, HP and MT cars, DISP, and that equals 0.79, right? Almost 0.8, and it indicates here. But with the larger variations, you can see that it has lower value, lower correlation, a bit lower, a tad bit over correlation comparing to the first case, probably because of this point. All right.